Hello everyone, welcome to tjSTAR. My name is Jordan Lee, and today I'll be presenting an Android mobile app called Studia, a social networking app for students that can be used to form study groups. Raj Bareda and I have been working on this over the past year, and today we're going to show you what we've accomplished so far. Section 1, Introduction. We've had several goals when creating our app. First, we wanted to find a way to connect students virtually since they've been physically separated due to the pandemic. And we know that due to the separation, many students have found themselves less motivated to study. By grouping students together with this app, we hope it can revitalize studying habits. And in the app, we wanted to implement features that allow you to create your own groups, communicate within them through a group chat, organize and classify groups by school, subject, class, and more, and search for groups based on these specific parameters. Section 2, Background. So first, why do we need a study group app? The first thing we looked at was a study by Jingwen Zhang, who researched the effectiveness of a mobile fitness app to promote physical activity. He found that the app that used social networking, or brought multiple users together, was able to effectively encourage physical activity more than an app for solo users. If social apps can have this effect on physical activity, we wondered if the same was possible for studying. The need to encourage studying is only growing as students are losing motivation to study. In 1961, college students spent an average of about 24 hours per week studying, and now it's only 14 hours per week. Additionally, with the COVID-19 pandemic keeping kids inside for online school, many students report feeling less motivation and productivity. However, another study found that regular communication with others is correlated with academic performance. If we can somehow connect students together, there's a possibility that we can help boost their motivation to study and give students a chance to keep each other accountable. Android Studio is the official software or integrated development environment used to develop Android apps. It uses Java as its programming language and XML for design and layouts. Gradle is its build system. Android Studio allows you to code for activities, a class that defines what the user sees on the screen and how they can interact with the app on that screen. Activities typically correspond to certain app features. For example, a social media app will have an activity for scrolling through posts and an activity for viewing your profile. There are also fragments, which almost act as mini activities that allow you to have a multi-pane UI or multiple things going on in an activity. Activities can hold multiple fragments that can appear all at once on the screen or be switched back and forth. Different functions within an activity can be divided into different fragments. Fragments are convenient because it can also share data with each other and handle it in different ways. Firebase is a backend service developed by Google made for mobile and web app developers, providing multiple services. Firebase authentication gives us an easy-to-use API that allows us to create user accounts on an app, handle logins, logouts, registering, etc. The Firebase Real-Time Database is a cloud-hosted NoSQL database that syncs data across all clients in real time so that app users can access data and receive automatic updates. It can hold simple data like strings, integers, and booleans, storing it all as JSON in a tree formatted with key value pairs and parent-child relationships. This allows for a hierarchy of data where certain data points can be stored under other data points, which helps us to organize data in the database. Firebase Storage allows us to store files such as photos, videos, PDFs, and more using Google Cloud Storage. Firebase UI is an open source library that allows us to conveniently display data from the real-time database on common UI elements, which update in real time. There are also 3 external libraries that we used for our app. Android Image Cropper is a library developed by Arthur Teplitsky that opens an activity where you can crop images, zoom, rotate, and flip them, and save your final product. These images can come from places like your phone's camera, gallery, Google Drive, Dropbox, and more. Picasso is a convenient image downloading and caching library developed by Square Inc. It allows for image loading onto your app where you can download images from places like URL and easily load them onto UI elements like image views. With Picasso, developers can display images on apps that come from anywhere online. Lastly, Circle Image View is a simple library developed by Henning Dodenhoff that adds a custom image view to your app where you can display images within circles. Section 3, Development. First, I'll show you an overview of our app. So here are the different activities that we developed for our main app features. First, there's main activity, which is the default activity that the app opens up to. And there you can view what study groups you are in and also create your own study group. We also have an activity for login and registering so that users can create their own accounts and sign into them. There's also setup activity, where users can set up their main user account data such as their usernames, birthday, and more. And search activity, which is composed of 3 fragments, users can search for different study groups that match the different parameters that they want. Lastly, there's group activity, where users can access all the features that study groups have to offer. It's made up of different fragments, and the fragment that we did develop was message fragment, where users can communicate in a group chat. And if you look to our flowchart on the right, it shows a quick overview of all the different features we have and how they connect with each other. And if you look at the green, those are the features we were able to develop, and the red are all undeveloped features. Our first feature is signing in and signing up with login activity and register activity. Using Firebase authentication, which handles login, logouts, and registration, we were able to authenticate accounts with email and password. Every time a new account is made, Firebase generates a unique user ID for it. One important thing we had to code for was validations, which check to make sure a user is signed in. In main activity, the app's default screen, we check for this. If the user is signed in, they can stay and access the app's features, but if they aren't, we send them to the login activity. In the real-time database, this is how we wanted to store user account data. We have an overarching branch called users, and within it, we store user data under the unique user IDs generated by Firebase. For each user, we wanted to store their bio, birthday, first name, gender, the list of study groups they're in, the number of groups they're in, their last name, a URL to their profile picture, their school, user ID, and their username. In setup activity, users can initialize their account data so that it will be stored in the database. What they enter into the text fields will be added to the database under their ID. To make sure all usernames are unique, we check if their input username is already in the database. But this will require us to read through the entire users branch. This will load up other data like first name, birthday, last name that we don't really need. So to save up how much data we load, we created a separate branch in the database just for usernames. So instead, the app checks if the input username is in that branch and only loads the data that it needs. Using the 3 external libraries, we also allowed users to set up their profile picture. First, we use Circle Image View to display a user's profile pic in a circular shape. Tapping this profile picture icon opens up an activity to crop images from your phone's photos with the Android Image Cropper plugin. Then, we use Firebase Storage to upload the cropped photo into the cloud. Firebase Storage provides us with a URL to the image, which we store in the real-time database under each user. And lastly, with the Picasso library, we can load the profile picture from that URL and display it on a circular image view so users can see their pictures. This is how we store study group data. Each study group is marked by a unique, randomly generated 6-character ID stored under an overarching groups branch. Under each ID, we store key group information like class type, which is whether it's an honors, AP, or regular class, description, username of the group creator, group ID, group name, whether it's filled, whether it's public or private, the max number of members, the number of current members, period number, the URL to the group's profile picture, a list of users requested to join, school city, school name, school state, subject, teacher, and the list of users in the group. Main activities where users can see what study groups they're in. I used a recycler view, which is a scrollable UI element from the Firebase UI library. It updates live and displays group data from the database onto layouts that I designed. To display the scrollable items, I created a group list item class that would store the data that I wanted to show. Name, subject, class type, owner, number of members, group ID, and the profile pic URL, which I displayed using Picasso. The recycler view is directly connected to another database branch called the Groups of User branch, which stores the group data that I want to display for each group under each user. I did this so that in main activity, it doesn't load up all of the study group data, but only the ones that we need. Each item in the scrollable list is attached to an on-click listener so that when you click on it, it will take you to Group Activity, where users can enter the study group and use its different features. If you click on the floating action button in Main Activity, you can create your own study groups by entering the desired values for your study group's data. Once you click the Create button, it updates 3 branches in the database to add this new group: the Groups branch, the Users branch, and the Groups of User branch. It's a scrollable layout of text fields, buttons, and also lets you upload a profile picture for your group in the same way we did in Setup Activity. It also uses Auto-Complete Text Views, an Android UI element that offers a drop-down list of suggestions to enter in a text field. It also autofills a text field for you. This is used to show a list of possible subjects, class types, and schools for your group. For the schools drop-down list, it pulls the suggestions from the database, where we have a schools branch that stores the names, cities, and states of different schools. And if users want to add a school that isn't there, they can do so in the Add School activity, which updates the school branch with whatever the user inputs. Search activities where users can search for study groups to join. It's divided into fragments that take care of different features. In Search Filter fragment, users can enter a group ID to directly join that group, similar to Google Classroom. And when they successfully join that group, a custom toast appears to show that group's information. It updates the Groups, Users, and Groups of Users branch in the database. Users can also enter their desired group parameters so that they can get a filtered search when looking for groups. They can specify the school, the subject, class type, teacher, and period. And the user's inputs are stored as static variables in search activities so that they can be accessed by other fragments. In Search List fragment, users can see a filtered list of study groups that match the values they put in. We used a recycler view to display a scrollable list of the groups. The app will look through each group in the Groups branch of the database and add that group's data into an array if it matches what the user specified. There's also a search bar where users can specify the group name, and when users enter a name, the app will perform a query on the Firebase database, looking for groups that match that name. Using the Unicode UF8FF provided by Firebase, it also allowed us to filter the list of groups that not only exactly match the user's input, but closely match the user's input. And when you click on a group item, it opens a fragment called Search Group Info fragment, which acts like a pop-up window. It displays group info and allows you to request to join that group. However, we weren't able to develop this requesting feature yet. To implement a group chat, we created a messages branch in the database to store all messages under each group. Each message is stored under a unique ID and contains the message text, the time it was sent, the user ID of the sender, and the study group ID. Whenever a user types a message and clicks the send button, we use the Firebase push method to gather that message's data, like the text and time, and push it onto the database. Push will generate a random ID to store the message data under. And to display sent messages, we use a Firebase child event listener, which is a class that listens for any changes in the database and takes action on it. So it will detect if a message is added, and if that happens, it will add a text bubble to the scrollable layout containing the message text and the username of the sender. And so this group chat was the only study group feature that we were able to finish. Section 4, Conclusion. Although we couldn't fully realize our vision for the app, we're glad that we were able to develop it enough for functionality. Users can get accounts, join groups, and talk with other members. And we believe that once the vision is completed, it has the potential to connect students together for the shared goal of studying. In the way that the app is designed, we hope that it can be conducive to learning and collaboration. And we believe that Studia can bring school communities together and help students develop healthy studying habits. There are many undeveloped features we hope to implement in the future, such as scheduling meetings and allowing users to request to join groups or invite users to groups. We also hope to make the app more interactive by letting users create flashcard sets or share study materials. And we can also make existing features more user-friendly, such as improving the group chat interface and allowing users to send files, photos, and more. Section 5, Works Cited. The following are all the different sources and references we used to make this research project possible. Thank you all so much for taking the time to watch this. I hope you all enjoyed and learned something from it, and have a great rest of the time at tjSTAR.